Ah, so I'm just seeing the delay here. Wow. Okay, the music stopped, so I'm not allowed to dance anymore. I mean, that's what everybody came for, Herbert, anyway, to see me dance. Like, it's what I'm. Who doesn't want to see a 53-year-old man dancing? I don't. I mean, really. All right, are we live here? Because I feel like I think people can start seeing us now, which is cool.
Yep, I think we're live.
Sweet. All right, my name is. Oh, somebody look at the clapping that's going on. Wow. So my name is Bill Kennedy. I'm a Go developer and have been one for about 10 years. So I'm here to try to talk about the Go side of this conversation. Herbert.
I'm Herbert Wolverson. I've been a Rust developer for about 5, 6 years. Before that, I was deeply in C and C++ land and Java and just about anything else I could find because I tend to just have fun. I am here to talk about the Rust side of things, and let's see what we've got.
Awesome. So I really want this to be dynamic and not boring. Herbert and I have not prepared for anything that's about to happen. I could tell you right now, my Rust knowledge is very limited to a few programs, but I have a general kind of idea of how Rust is different from Go. And so hopefully some of that will come out and come up. And I'm hoping I can learn some stuff from Herbert along the way. So, what I want everybody to do is we'll start talking a little bit here. But if you have questions, we can see the questions. We've got about a 30-second delay here. So from the time you ask it, from the time I see it, there'll be a little delay. But throw those questions out there. We're going to be here for about an hour, maybe a little longer if we're like in some heavy, heavy conversation. But let's kind of do that. So, you know what? Maybe I'm going to start with a quick question for Herbert because I don't get to talk to Rust like experts very often, and I kind of know. I feel like I know the answer to this for Go, but from a Rust perspective, where do you think the big sort of strengths are for building, I guess, back end services, and maybe what are some of the I don't want to use the word weaknesses, but maybe where Rust struggles.
Okay, so on the positive side, Rust itself was started out as a basically a safety feature. Um, Mozilla Labs were having loads of fun with memory safety and all sorts of things breaking horribly, and it started out as a side project and eventually started becoming part of Firefox, became its own big thing. And so, building from the very beginning with a borrow checking system that prevents you from having data races, unsynchronized access to variables in memory, and then adding to that, it makes concurrency a lot easier because suddenly you don't suddenly it won't compile if you're accessing your data insecurely. And on top of that, you've got years and years of learning with all the things that went horribly wrong with C, like strings that if you miss the zero on the end, you just keep reading, um, right past the end of an array and corrupt your memory. And in the past, a lot of languages had solved that with garbage collectors. I mean, Java was the poster child of that for a long time. And then Go came along and honestly did a really great job of taking care of most of the, you don't overflow your buffer and suddenly somebody owns your server completely. But Rust was positioned kind of lower on the stack, so um, Rust is where you want to be if you need to actively control your memory, control your threads, control your green threading within those threads. Um, and so that leads to both a strength and a weakness. And the strength is you can really do anything. And the biggest weakness is that you can really do anything. And you're going to have to spend the time to actually build the layers yourself sometimes. There's a really strong library system called crates. So you can put together a really high performance web server in about 20 lines of code. But once you need that web server to do something really special, then you're going to be writing some code. And also, a lot of people, their first reaction to the Rust syntax is, "Oh God, what am I looking at?" And the reason for that is that the people who first came up with Rust really loved the ML series of functional languages, wanted something like that, but they also wanted to keep some bits of C and bits of Java and some C sharp type syntax started to sneak in. So you ended up with kind of a hybrid syntax. And so when I'm teaching the foundations class, the first thing is don't be as terrified. It really is similar to what you see. It just looks very different. And Rust really doesn't let you skip the steps. So if you need a thread, you need to create it, and you need to worry about what will happen when that thread finishes. Some languages let you elide that a little bit. And Rust gives you all the tools you need. It just doesn't always make it as obvious as I'd like. And the one that always comes up is that Go has an amazingly fast compiler, and Rust really doesn't. There are ways to tell you very quickly, oops, my syntax is bad, this isn't going to compile. But it does, once you start getting into really big projects, running a build can still be a bit longer than it should. It's getting better all the time, but right now it's occasionally a complete rebuild is coffee break time. So I think
All right.
that's probably.
Yeah, that's awesome. The one program that I wrote that I kept asking you for help on wasn't a multi-threaded program, but you had to beat into my head several times this idea of pattern matching when it
Oh
came to
yeah,
like handling, when it came to these sort of templates. And maybe you talk a little bit about that because that seems to be a big part of the language.
yeah, it really is. Rust at its core went with algebraic data types, which look like an enumeration, but you can keep adding. You can add variables in. You can attach functions to enumerations or to even enumeration options. And because they're a sum type, you're absolutely guaranteed that only one of these values will exist. So you might have, on the top level, you're authorized to log in, you're not authorized to log in. Well, that's great, but there's probably going to be a reason. And so in a C style enum, you'd have not authorized password bad, not authorized banned. Or Rust, you can take that not authorized, throw in another structure, and store all the details you need there. Or you can pass authorized with a token, and only one of those will ever exist at a time. So the ADTs, the algebraic data types, go all the way down to null pointers, which are completely replaced with an option, which are either some or some containing some data, or none. There's nothing here. And then because you have to use match to or its sibling iflat to read the contents of that, you can't accidentally ignore that. Hey, I just dereferenced a null pointer, and that killed a whole class of bugs. And after a while, once you're used to pattern matching and extracting things out, it's very rich. You can start reading. Okay, so this sum contains an enumeration. Well, we're going to make this match branch match not just that there's some data, but the data in the side is authorized and the token is equal to 3. And so you can do that in one line of code, makes it very expressive. At the same time, once you're um, once you're new to it, sorry, when you're first new to it, it's a little intimidating. That's why I always start with enumerations as the first structure I teach, because really almost everything in Rust is an enumeration or a structure. And once you've got those two down, you've pretty much got everything.
I think one of the things that was driving me crazy trying to learn Rust that week, and I'm used to it from Go. I think one of the things that was really nice about Go is in general, there's really like one way to do things, and there isn't a
Yes.
lot of complexity around that. So there really is just one way to handle errors, right? There's the error interface, you define a concrete type that satisfies that interface. And so value errors in Go are just values, and we can move them around the program in a decoupled way. And I think I can have one conversation with somebody, give them one example, and I think light bulbs can go on, right? When it came to that Rust program and the pattern matching and the options and all that, um, and seeing multiple ways of handling that error and wanting to be more granular than um, opaque, right? More transparent than opaque.
Hmm.
Started pulling my hair out a little bit because I was saying to you, what's the best practice? And you were like, this is. But I'm like, I don't like that. I want to be more transparent. You're like, well, then you do it like this. I'm like, no. you know,
Yeah, they've honestly given you too many options. Unwrap is the easiest way to handle any error whatsoever. You say if it's an error, then please crash the whole program. I don't recommend that in production, but it's handy when you're learning. You can match on the error. You can match on if it is an error, and there's the question mark operator that if you're returning a result, you can just throw the result all the way out of your function and let somebody else deal with it. And I do agree that there's arguably too many ways to do it, and the um, default mechanism for building an error is kind of messy, which is why the Rust world as a whole is standardized on two solutions. One called Anyhow, which catches almost any error and is what you use when you just want to say something bad happened. So whatever I just called didn't work. And then there's one called this error, which makes it really easy to write really explicit error messages. So if you're doing something low level and you care that the issue was that the file didn't open versus the buffer didn't work when you opened the file or the permissions were wrong, then you can start getting really granular. And there's a bit of tension there because when you're writing a web service, you don't necessarily need to know exactly what went wrong depending on versus when you're writing an operating system driver module. Whereas if you don't trap the error exactly, you might cause somebody's video card to futz and mess up their whole day. Um, so Rust really tries to do both, and that's why there's more than one way to do things. And I typically try and focus on teaching the what's become the de facto standard, which is this error and anyhow. I think it'll become part of the standard reasonably soon. The standard library eats, absorbs crates that are doing well like that.
so I just want everybody to know I see those questions. I'm on the YouTube as well, and I'm going to get to all of those sort of as I see them. So keep them coming. And Deem, I love that you're reading that book. I think it's good. I think having a design philosophy for everything you're doing keeps your head straight, right? And we can even just have a show one day on what the design philosophies of Go and Rust are,
Yeah, yeah.
right? I mean, they're critically important. So
And one thing that Rust both benefits and suffers from is that it's an open source project. So the design philosophy is kind of democratic. There's a lot of people on the core team who have a philosophy, and it's almost up to a vote what will come in and what will not.
So I think we've had these discussions over 10 years related to in Go. Go is an open source project as it relates to the code base, but it's not open governance.
That's right.
And this has been at times a struggle because since the governance is closed, people have felt like it's truly not open source. But I think the closed governance has helped the project much more than it's hurt it over the years. Now, do I expect everyone that's currently on the Go team, and we've seen it already, stay in Google for the rest of their lives, like Russ Cox and Ian and others? Probably not. So then I think it gets interesting what happens when they start to leave, because we're already seeing people like Brad Fitzpatrick and Tailscale, right? A bunch of people on the Go team that are contributing back, and they get to continue to participate. I think in some of the governance, which is really cool. But I think the closed governance has really helped the project more than hurt it. I mean, you're saying Rust really has open governance.
To a large extent. I mean, the people who've been around the longest get listened to the most. Um, the core team who come up with general direction stick to a set of principles that are up on the Rust Foundation website, and the basic message of safety first is not going to go away. At the same time, it evolves quite a bit. For a long time, static global variables were a pain in the butt, and everybody, literally everybody, was using this one crate called once cell. And because of that, now once cell just joined the standard. So it's good to see the evolution like that. At the same time, it's a little harder to say for sure where Rust is going, if that makes any sense.
Yeah, I think the biggest problem sometimes, and the Go team has solved it again, I think, with this closed governance and being very clear with the backwards compatibility promise, is that programs you wrote 5 years ago still compile today and are still as readable as they were. I mean, we've learned new idioms, we've learned new ways, and we've got some new packages and things. But I think having that backwards compatibility promise and not changing the language a lot, just improving on idioms as much, not so much as changing them, has helped tremendously.
Now Rust does have additions. So if you tag your program as using the 2019 edition, it is absolutely promised that it will continue to compile unless a feature you used turns out to have been such a bad idea that it's actively blowing up servers somewhere. So they do make a guarantee that your code will continue to compile. They do not make an ABI guarantee that it will continue to link exactly the same.
All right, there's some questions coming in. I want to get to them, and some nice practical ones, like what types of applications would you build in Rust versus Go? And so I think one of the things that the Go community gets to kind of pound their chest on a little bit are some big projects like Docker, Kubernetes, are the two big ones that come to mind. A bunch of databases that are out there, the TensorFlow stuff. I mean, like over the last 10 years, I think some of the most important tech has been written in Go. And I think we all can appreciate that these projects have been highly successful using Go. So I'm curious before we go any deeper into that question, what are the projects that the Rust community kind of get to pound their chest about? Like these are our projects that are showing that Rust is a viable candidate to build software in.
Well, let's see. On the lowest level, Microsoft just announced that they've replaced large parts of Windows with Rust and are continuing to do so, and declared that they're on the um, kernel to user space boundary. They are seeing approximately 80 to 90% fewer in the way of memory related bugs, which is a huge improvement. Um, then Google have been using Rust heavily for their new operating system development, and also like the Android Bluetooth stack is now written in Rust. Um, Linux itself, there's only two languages in the kernel, and Rust is one of them. Until last year, it was just C. And that has actually been bearing all kinds of fruit because the Rust safety checkers have found bugs in some of the other parts of the Linux kernel. And the Rust community really pulled together to make a lot of changes needed to work well in the Linux kernel space. And Microsoft have been making some changes to make it work well with the Windows kernel space. Apple's kind of the odd one out in that they haven't announced that they're doing anything with it. So on the very lowest level, you've got that. Go working your way up. Influx just moved to Rust for Influx DB3. That was um, quite a spectacular announcement because they didn't really tell us that they were going to do it. Um, there's where you tend, Amazon love talking about Rust. The back end of AWS is almost entirely Rust. The front end uses a mixture of Go and apparently some really interesting scripts from what Tim McMorrow was saying. But they switched to Rust for that because it's extremely predictable on latency. So if you need to get your AWS server, which is probably running a Go program, up and running quick, then Rust is great for orchestrating that place where you need the performance in a hurry. And so the other thing I keep seeing is that Rust is really great to integrate for part of a project. And that's something I'll actually be talking about in a webinar next week. Is you might write your whole program in a nice, comfortable, high-level language, and then this one algorithm that is such a pain to optimize and uses all the resources, write it in Rust, compile it as a dynamic library, call it from whatever you want.
Yeah, except Go's CGO sort of integration adds layers of sort of latency between that. So I think you could do that. It would almost be fun to maybe you and I get together one day and try to do that and see what's involved in getting a Go program to call into a Rust
Yeah,
package.
I was actually playing with that, ready for the webinar next week, and the delay is about 10 times the delay you get in C for calling into a library. But as long as you make sure that Rust has enough to do to amortize out that time delay, it's not too bad. What you don't want is make 100 separate calls in, because each of those is going to slow you down. Make one big call in, and it's not too bad.
So I'm always focused on the average developer. I wouldn't call people that are working in the kernel or the drivers or some of the projects that you've, which is amazing. I mean, the thought that Microsoft is starting to use Rust to write their kernels wild. But the average developer is mainly building web services out there. They're running Lambda functions. They're moving data around. They're driving UIs, browser, mobile apps, all of that, right? Like that's like a bulk, at least, of the world that I get to see. I consider myself an average developer. So in my world, Go has just made the things that the average developer are building just so much. I don't want to use the word easy. I think more obtainable to build those types of things and to build them in a way where those programs were going to be solid, right? With the memory,
Hmm.
with all those things that we've talked about. And so I still think that Go is just this has this amazing place in software development because the average developer can get up very quickly. Within a couple of weeks, you can build your first service and get it in production. It may not be the most prettiest, most idiomatic code, but it's going to work. And the runtime and the compilers are already there helping to optimize much of even your inefficiency away. Um, what about that average developer? Like, if they needed to get build something, there's two people here, right? That I kind of want to talk to you about. There are the people that have already been maybe for the last year or two or three building services in Go. They're having success. Go is giving them the performance that they need. Is there a reason for them to think about maybe switching to Rust based on building the same sort of products and services? What about that person who's just coming in? They're coming out of Java, they're coming out of C Sharp, they're coming out of PHP, and they want to set a career path now for the next 10 years and still try to do things in the next, say, month or so. Like, I'm really curious about your opinions because my opinion would be start with Go. If your timetables are, I need to get something up and running in a month or so, and I need to make sure that it's solid, and then I can expand and build on that later, as opposed to Rust. But again, I don't know Rust. I've struggled with Rust a little bit for a week, but I'm really curious what your thoughts are there.
Yeah, so Rust isn't the most friendly system to get going in, but the 4 day class I taught, I think it was last month, sorry, 2 months ago, um, starts with Hello World, and by the end of the first day, you've got a functional command line interface that lets you add, remove users, serialize them out to JSON, and by the end of the week, you're writing network servers. We spent an hour throwing together a web service because you've got systems like Axum, Rocket, and similar that you can really get a web server in 20 lines of code if you are willing to follow through a tutorial and keep building on that. Like on the LibreQOS project, I had a fellow come in and say, this really needs WebSockets. And then he said, I've never used Rust before, but I'm really good at PHP and Python. And 2 days later, he sent me a PR. He had figured out enough Rust from reading tutorials that he'd built a whole WebSocket server, added it into our project, and it worked beautifully. And so it's there. The learning curve is harder. I will say that, from when I picked up Go the first time, I was productive very, very quickly. When I first picked up Rust, I spent a lot of time wondering why everything was different from C++. Um, on the other hand, it also kind of depends where you want your career to go. Go is not going anywhere. It's not in the. I don't mean that in the bad sense. I mean Go is going to be around for a long time. It looks like Rust is going to be around for a long time. I'm a believer in using the tool that you like, the tool that suits the problem you're trying to solve. And so if you like having the option of tackling the really lower level stuff, Rust is great, and there are tons of people who need you. If you like to be very productive very quickly producing web services, Go is great too. Um, I'm not going to say anything about Java because I got burned horribly in the J2EE world, but
So, one of the things that I've really focused on in the last 3 or 4 years is that ultimate service repo, that ultimate service class, this sort of starter kit for building production grade services in Go. And the more projects I'm on, the more I sort of bring it back into this. And I call it a starter kit, not a framework, because it's literally a starter kit where you start from. I start every client project with this. And then we rip out what we don't need, build in what we do. But there's a set of design philosophies and guidelines and all of that I'm trying to write up in a book right now. Um, does Rust have anything today like that? Is there any sort of starter kit where it shows an MVP of best practices for, let's say, a web API? Mine manages a garage sale. There's users, there's products, there's sales, there's all these things. Are there any projects out there like that that can be leveraged for somebody starting with Rust, where you build it, this is working, great. Now I have this sort of foundation to start from.
I would say buy Tim McNamara's book on Rust. If it is full of practical projects that start from not quite zero. He assumes you know a little bit of the language, but shows you some great ways to accomplish a few different things, ranging from writing your own little virtual machine to if you want to communicate over a network. I actually saw in the chat somebody asked, "How do you know which crate to use in Rust?" And that is a tremendous problem, in my opinion. It's something that Rust really needs to work on the teaching front. There are some really great ones like Axon, SQLX, um, Takio, which underlies an awful lot of other projects, and Rayon. Um, what there isn't is a nice little start here guide. There's an awful lot of blogs. Um, when I wrote Hands on Rust, I wanted to teach the language. I'm still looking for somebody to write from C to Rust. So if anybody wants to write that, just shoot me an email. Um, but I do think there's a big opening there. Somebody needs to write that, and I'm doing my best to teach it.
So something that's come up from Dima is WASM, right? Like I've heard of WASM for probably 8 years, and I've been waiting for WASM to find a home, right? That the promise was in the browser. We're going to run things fast, and it seems like finally, I think there's a home for WASM in the embedded world, and it's my understanding that Rust has really been in the frontier, the head of this sort of WASM curve, where they've always had the best. I don't know, it's a WASI compiler. I don't know what all the language terms are here, but let's just say WASM, being able to produce WASM better than any other language. I'm now hearing that the Tiny Go project is about to put some native WASM support in. Even the Go compiler, I think in the next release, is going to have some new architectural flags for this. So it seems to me that WASM's finally really getting the right momentum and uh, going to find a home in the embedded world. So, what kind of project is this? Your same sort of? Are you seeing the same things, or am I just way off?
Yeah, Wasm is awesome. So my first experience with it was back when there was a hacked together C++ compiler, and I was working on a website that did radio propagation studies, and some of the math was just too slow in JavaScript at the time, so I tried out this WASM thing, and even then it was literally a 10 to 100 times speed up in the browser. So when Rust announced full WASM integration, first thing I did was I took the roguelike tutorial that I'd been working on, which Stan Wigler just called out, and I compiled it for the browser. I had to change a couple of lines of code because threads work differently, and everything else just worked. Even the OpenGL, putting the game on the screen, um, it really was just fantastic. I've never seen such great integration. And now WASM is built into Docker. You can compile your services. send them off, and they're pretty platform neutral. You don't have to care what kind of computer is underlying running them. Wasm's pretty tiny. You can send it off. It'll run on a Raspberry Pi. It'll run on a supercomputer. The only downside is that Wasm threads are really, really weird. And so if you need to spin off a large amount of heavy compute, you're going to have a lot of work to do. It can do threads, but they work differently from, well, every other thread I've ever seen.
So I'm going to switch gears just a little bit. I had a conversation maybe a year ago with a friend whose shop was building a bunch of services in Go. And then at some point, they decided that a certain class of services were going to be written in Rust. And in a general sense, I asked why. And the answer was they had some needs where they had to remove latency, not work within the scope of latency, right? So, as an example, if you've got IO bound workloads and you're hitting databases, that's IO bound, right? You're waiting on the network for things. Those are IO bound workloads. There's a lot of time between the request and the response. So in that sort of environment, GC doesn't hurt you. Having a lot of concurrency doesn't hurt you because you have all this dead time in between these application threads needing CPU and not needing CPU, right? And so this is when I'm trying to teach concurrency and Go. I'm always like, Go is great, and I have to show you how to allow the latency to work for you, not against you. How do we get latency to work for you? By making sure that when one thread is no longer needing a CPU, there's another one there ready to jump on, right? The latency isn't hurting us. It's, if anything, we're going to make it work for us. But in this one case, my friend was like, we don't have that situation. It's not about, well, this just stopped, so we're going to do something else. I need to remove latency out of the system. I just can't have it. Like, we're that time critical. And so they started building some of those services in Rust because it was more about removing latency and not so much about living within the scope of making latency work for you. I'd love to hear some of your thoughts on that.
That is honestly very wise, because um, you can use the same basic green thread setup as Go if you want to with Rust's async await. But where Rust really shines is when you need to really tightly control. Okay, so you've got a memory pool. I know I'm never going to escape that memory pool. You, I've got threads with deadlines. I might be working with real-time OS even, and you can get down to some really low-level, highly optimized code. Rust is phenomenally performant when it comes to heavy number crunching, whether that's encoding JPEGs or um, handling crypto or anything like that. I actually saw a project that sped up PNG decoding by a factor of almost 12 the other day, and they were just using that as a tiny function on a large website because they needed to read PNGs coming in, handle them very quickly, and get them onto a live TV broadcast. And so it made perfect sense there because you've got to reduce that bit of latency in there as much as you can. Or open source. My favorite open source project right now is LibreQOS. We read packet data directly from the kernel over what's called XDP Express Data Path, and um, track times down to, we've got it down to about 100 nanosecond granularity so far for being able to graph your packets, show you exactly what's going on in the network. And this is being used by the fellows who worked on the Cake traffic shaper so that they can see what's actually going on and fix your network. And so once again, there's honestly, if I wrote the visualization code in Go, it would be quite a bit smaller. But I'd also have a heck of a time meeting those deadlines when the kernel is throwing ring buffer data at you at basically I'm limited by memory bandwidth and how fast I can read what it's sending me, if that makes sense.
Yeah, and so this has kind of been my measuring stick of telling people, is what you're building going to have inherent latency already built into it? And then can we leverage concurrency to keep the CPUs busy, right?
Yep.
While there's a latency. Or do you have a situation where it's quite the opposite? And I'm not just talking about CPU bound workloads; it can still be IO bound. But the bottom line is that we got to remove the, like, a browser to me is a great example, right? There's network activity going on. Obviously, you're requesting and downloading data, but rendering that screen as fast as you can without any interruption is critical to the user experience, right? You don't want a GC in the middle of that, and you wonder if the page broke, right? And there, to me, the browser is an example where there's still networking going on, but when that data comes in, it's almost like you need full throttle on the CPU without any interruption. And once that's done, we can go get some more data, maybe. Like, so that's been my measuring stick for when you should start to consider using Rust. When your problem is within the scope of that latency domain.
Yeah, I'd agree with that. Um, Sorry, I just saw a question scroll by, and it scrolled by faster than I.
There's a great question here that I didn't want to get to, and I've asked this before, and I've given advice around this before. And it's, how do you convince a company, even a traditional company, to switch to either Go or Rust when maybe they're a Java shop or C# shop or PHP shop? How do you convince a company to and I'm assuming a company that you work at. And this is a really hard sort of problem to solve. So I'm going to give you my 2 cents, and I'm going to let Herbert sort of give you your 2 cents, because my job over the last 8 years has been training companies in corporate environments. Um, but 90% of the time is because they've already kind of committed to wanting to switch to Go for anything new that they're building. I've had, in two occasions, walked into a training room where it's management that wants to switch and not the dev team. And that is not a friendly environment. And so for me, this has to come from the bottom up. When it comes from the top down, it just gets, if you don't want to learn it, you're not going to want to learn it, right? But what I always say to people is, find a small problem that you have that hasn't been solved yet, or some sort of service you've written that's doing something fairly small but it's failing, or failing the company in terms of not crashing, but not performing enough or not something enough. And take your free time and build a Go service that solves that problem, and show your tech lead, your manager, show how what you just built in the small amount of time that you built it has improved that situation that you see in front of you. I have seen that work. I've heard about that working over and over and over again. But what wins that conversation over with the management team isn't just the fact that you've solved some performance problem or some reliability problem. It's how fast you wrote that on your own. That seems to be like the magic wand, that light bulb. Like, hey, I built this in 3 days. What are you talking about? It took us 3 months to build that thing. I know, but I just built it in a week. And look, it's performing better. So I'm curious, Herbert. Like, that's my advice. Solve the problem
Um,
with, and show them how quickly you were able to do it. That code doesn't have to be perfect, but it works.
the funny thing is, I would have used almost exactly the same example because I always tell people that you find a trouble spot, um, find a trouble spot that's good for the language you're trying to evangelize. You solve the problem, and then you go around and you make sure that your teammates, your managers, and everyone know that you solved it. You solved it in a reasonable time, and there's some tangible benefit to it. So maybe it's solving a performance problem, maybe it's faster, maybe it just actually gets the right answer consistently every time, or maybe it even tells you what's wrong. And the I never recommend working for a company that announces they're going to forklift everything and we're going to be a Rust shop, 100% Rust shop next week. You are much better off always taking it gradually, one service at a time, one project at a time, and that's really the a way to productivity, and also your company benefits from not being a monoculture. That way, if something happens on one of the platforms you're supporting, There's a real benefit to having other platforms as well because you can always find more people. You can leverage that knowledge, save the day when things go horribly wrong.
So here's another cool question. And I felt like I ran into this when I was writing that blog post on Rust. In Go, we have a general community guideline that says it's better to copy and paste a little code than to, let's just say, create another package or dependency, right? Because we have a we have this thing I call package oriented design, where everything is a package that's built into libraries. So you want to reduce those into dependency trees, right? So copy it into the other package. Don't create an import to that, right? Don't create that dependency. What I noticed about Rust was, and the person asking questions, kind of the same thing. It was the opposite, and I saw a lot into like a generic type. So it can be just about anything we need it to be out of the box. That made my stomach curl in the beginning because I felt like I couldn't just build concrete types to start and then discover, say, those abstractions or discover when I actually needed that relationship. It was almost like the opposite. Start with this level of abstraction and then move on from there. I could be wrong, but that's the impression I got.
Um, so the crate system is wonderful. There's like 100,000 crates, though. Nobody can possibly know which ones are good, and so I really recommend sticking to some of the big ones um, and using those. And then when you encounter something like, you know, practical example, I needed a high performance lock free concurrent hash map. I asked around a bit and finally found there's a crate called Dash Map. Had a look. It is amazing. So I started using it. Highly recommend it. Um, but before that, I actually wrote a bit of lock free high performance code myself, and it wasn't up to snuff. So it didn't do the job that it could have done if I'd carried on with it, but I'm glad I looked. So I go both ways. Cut and paste a bit. If you realize that this project you have is something that you're going to use over and over again, make your own library. If you realize it's something everybody else might use, make sure there isn't already one. If there is, then feel free to share it because you just announced to the world that you're a decent programmer. Probably got yourself some attention, and now you're helping everybody else who has the same problem. Very, I tend to have a pretty collegiate attitude that if it's not the core of your business, then it's worth sharing how you solve the issue. Um, on the other hand, there is licensing issues. Be very careful um, if you're working on a proprietary project to double check that you're not accidentally pulling in something that's GPL'd because your managers will really not thank you. There is the cargo license tool to help you with that. Um, but um, I find that when I'm working with a group of people, there's usually one person who does some of the generic library level stuff, and everybody else uses it and puts it together and builds relatively straightforward, readable programs. Because I'm not going to claim that Rust generics are the easiest thing to sit down and read. They're really not. The trait system, though, is incredibly powerful. So just like C++, you can build almost anything with it. The question is, A, should you? And B, is it worth inflicting that level of pain on everybody in the team? And no, it's not. But if you've got one guy who can realize, hey, I've solved this problem for the 8 guys I'm working with, then great, use a library or build a library.
I got another cool question here from Dimitri. I'm going to give you my answer, and I think it's going to be the same as Herbert. If you want to integrate with an existing huge ecosystem of C and C++ code, which language is better? My guess is Rust because you don't have that marshalling layer with Rust, right? You have the same ABI. You can just make that call. It's as if it was calling into Rust code at that point underneath, right?
Yep, and it's really easy to include building C++ in your Rust build, and Rust is very friendly to be included in your C build. And then, depending on the flags you use, you can have compatibility with whatever, usually LLVM, but it can be other compilers, spits out, link to it, use it just like a library. I actually quite often when I'm asked to port something from C++, start by making a Rust project that compiles the whole C++ program and then just runs unit tests against all of the C++ functions. Then, as I port one function at a time, I run unit tests against both. And when they match, I can be pretty sure that I did it right.
All right. So there's a question from Ian, who works over at Arn Labs, but I'm not sure I got the full context of your question. Ian, he said, are these optimizations in Rust usually just implementing them in Rust, or is there typically additional optimizations that are just not possible in Go? It's like, yeah, do you understand that question?
Kinda. Um, Part of it is, the LLVM. One of the reasons Rust compiles so slowly is that the LLVM compiler toolchain seriously tries just about every optimization under the sun if you let it. Um, and the Go compiler is very fast and doesn't go quite to the same ridiculous extremes. Um, but I would say, that if you're willing to get into memory management, marshaling your threads independently, pinning them to cores as needed, and so on, Rust is giving you some stuff that Go would struggle with a little bit. On the other hand, you're going to write a whole lot of code, and so ideally you need that performance to want to do that. Does that make sense?
If there doesn't, Ian, we'll drop some more messages. So here's a question. I don't know if I agree with the question, but these two languages are new and entry level roles are scarce. Does this not impact the adoption of the language, Go, especially senior developer? So for me, Go isn't new. Right? We're a decade in already. So for me, it's not a new language. And I am finding because, well, up until this year, because we know what's happening in the with tech jobs this year, but up until this year, I was seeing people coming out of school, out of undergraduate and grad school, getting jobs coding in Go kind of at an entry level because they had such of other backgrounds in data processing or analysis or physics or whatever it was that I think a lot of companies are okay right now with people that aren't necessarily senior or have a lot of Go experience because I do believe it's true that you could pick up the language and be productive in a month and then over time get proficient with it, right? So I don't know how true that is. I've seen a lot of companies that are willing to hire people with not a lot of Go experience because of that. I think confidence that you can learn it. I have no idea what the Rust job market looks like before and after January, Herbert.
Yeah, after January, I think everything's a mess. The um, just fun anecdote. Back in 2001, I just finished using C Sharp Final Beta to finish a project. Went to a jobs market and I found something saying that we need C Sharp developers with 10 years of experience. And version 1.0 was due out the next week. You will see that, and most of the time they don't really mean they need 10 years of experience. So when they mean senior, they want to see stuff on your resume that says that you have lots of development experience, know how to structure programs. Junior development jobs, it helps to know the language that you're applying for. You don't necessarily need to be super amazing at it. It helps to have got over the initial hump, and you can become proficient pretty quick. It's the easiest way to learn is to do things. Uh, what I will say is that I still see Rust jobs posted. I'm seeing more in Europe right now than I am in the United States. And I've been getting more LinkedIn contacts asking me to talk to people about Rust than ever before. Rust isn't that new a language. It's 10 years old, but people really only noticed it in the last 3 or 4 years.
So
Oh,
this is
and
a
can I
question.
can I just say Zig is an amazing language, but I have yet to see a single Zig job. If Because it feels like a hobby right now, but Rust was in the same place 10 years ago. So hopefully, Zig will take off. Zig has a lot of potential.
I was hoping to get somebody from the Zig community on here actually, because when I tweeted about this, somebody was mentioning Zig, and apparently someone has built a database right now with Zig. I have to go back and look at that. So I think there's a project out there right now that is um, sharing some success story with Zig. I have not looked at it. I would have loved to have gotten somebody from Zig here to talk about it. So, I mean, for me, every 20 years, some new tech, some new programming language sort of shows up, and they come and go as quickly as they hit my Twitter feed. Maybe Zig's the next. Maybe Zig's the next one 10 years from now. I don't know, but it might be fun to do one of these with somebody from the Zig community. This is a question that's just for you, Herbert. What do you think about the new Rust Foundation trademark policy? I don't even know what they're talking about. So,
Um, I get asked about this a lot, and honestly, I think the Rust Foundation did a terrible job of communicating on this one because they paid some lawyers, came out with a draft set of policies, and those policies are terrible. The community screamed at them. They're redrafting. They're going to come back with something from the people I've talked to that is a whole lot more reasonable. I don't think it's going to be a problem. And part of the reason it won't be a problem is that Rust had a trademark policy previously that was very permissive. And everything they've previously let you do that you're already doing is what's called in legal world estoppel. And once you've given the promissory estoppel that you can do this, you can't suddenly declare that no, you can't do this because that's unreasonable and would make the trademark indefensible.
okay, so we're down to really like our last eight something minutes here, and my marketing department wants me to do some stuff with you, and I don't want to get fired from my own company. So, um, with Eric, if you've ever taken any of my classes, and you know Eric Salaya produces everything we do, and he's sitting in the background. So, Eric, what do we got to do this raffle thing, or anything else that the marketing department wanted to do here at the end here? Oh, you wanted me to talk about this. So, oh yeah. So in May, I'm going to be teaching the ultimate service class again. I've made more improvements since version 4.0, which is out there on the education site right now. I'm pretty excited to teach it again, and then every time I teach it, we put that up on the education site. I have screamed at my marketing department to try to make this class affordable, especially right now, since the tech community is going through what it's going through. And I just want you to know that if you can't afford any of this, or your company won't pay it, and you really, really want to attend, send me an email to bill@ardenlabs.com, and I'll send you our scholarship form, and we'll make it happen. We're pretty dedicated at Arden to make sure that everybody gets the education that they need. Obviously, I got to put milk on the table. And so there's some pricing involved. But at the same time, we're not going to deny somebody access because they can't pay for whatever their reasons are. So it's critical to me that if you can't afford one of these options, that you send me an email. I will make sure that we work with you to get you access to this class and or the video content if you want it. But this class is great. If this to me is your practical Go class, you want to learn how to build services and think about them in a Go way, design philosophies, guidelines, idioms. I love this class. It's what I've been developing for over four plus years, and I think it's in a really amazing place. And we bring in just enough Kubernetes that the developer kind of needs to think about. And this code that we're going to be going through also runs in production. So it's good stuff. So Eric, that's my little pitch on the ultimate service stuff.
All right, next week I will be talking a little bit more about some of the topics we talked about today, giving a 1 hour free webinar on introducing Rust into your company ecosystem. I've got a few demos put together that I'm working on. This will be more of a high level talk than a get down into the nitty gritty. It's only an hour long. But we'll talk about where you might want to use Rust, where Rust can help you. We'll talk about ways to call Rust from Go. We'll talk about ways to call Go from Rust. We'll talk about Rust support for connecting at the network edges to talk to your services, whether they're written in Go or anything else. And overall, I'm hoping to show you some of the ways that you can use Rust to just improve the quality of experience that you're getting within your company.
Brilliant. Oh, Eric, what's the next thing that you want us to? Oh, sorry, Herbert's
Oh, here
got
we
some
go.
more stuff.
Um, and through May and June, I will be teaching Ultimate Rest Foundations, and instead of teaching it as a giant block of 5 days, it's being broken out into separate sessions that you can take independently. I'm doing that partly because with the way the economy is right now, not everybody can afford everything, and also because if you have already done the absolute basics, you could skip the first one, but you might be interested in system thread concurrency. You might be interested in async await. And so what we've done is we've broken out the same class and really focused down, deep dive, laser focus on a topic. So getting started with Rust really does just require that you have the Rust system installed on your computer and a text editor like Visual Studio Code that is working. Um, but you will come out of that able to write a basic command line application, understanding enumeration structures and variables and the basics of how to write a program. You'll be productive in a day. Fearless thread concurrency is a deep dive down into how Rust talks to system threads, how you can communicate between them, how you can marshal them, do things like make them divide up your workload, and we'll talk a little bit about a library called Rayon that makes a lot of this easier, and a system called Crossbeam that provides you with some of the extra stuff that one day will be in Rust. Async await concurrency is closer to the Go approach, where you have a thread pool and then you have tasks that run inside of each of those. That's what you use if you need to make a web server, a web service, high performance network server. Managing memory and resources, the borrow checker terrifies everybody. So, working with the borrow checker and realizing that it's not your enemy, it's your friend, is the focus there. And building network services is a start from scratch. And by the end of the day, you will have a high performance, low latency network server capable of receiving data from services, processing them, and spitting back replies.
So the only thing I want to add, because somebody brought up the junior level stuff again, I have had more than several dozen people be able to interview very effectively for jobs after taking both Ultimate Go and the Ultimate Service. I really think that if you're trying to prep for a Go job, even if it's say a mid-level job, these classes can help you because I really talk about design philosophy and guidelines and how to think, and I think that helps in the interview. So um, take these classes, and again, if here's another thing, at least for the Go classes, right? I mean, I can only talk for the Go classes here. Um, if you take these classes or you jump on the education site and the videos are not working for you, the class isn't working for you, you're not getting what you want out of it, ask for your money back. I'm not here to take your money. So there's no risk. Okay. So if you're having trouble interviewing for on these technical interviews, these classes are going to help. They're going to help. And you have access to me all the time anyway for questions. So I'm here to help you in your career and in your knowledge. So let's leverage that. And again, we have the scholarships to help you there. There is an ultimate service book being written. I'm working full time on a client project, so that has slowed down a little bit, but I kind of got at the end of that tunnel. So my prayers are that it's done by the end of the year, and it describes everything that I teach in that class, word for word, and just like we did with the Ultimate Go notebook. So same sort of book, same style, but for ultimate service. All right, Eric, what else do we got here as we enter into this last couple minutes that we have here? You want to spin a wheel or something like that? Oh, oh, lunch and learn. Okay, yeah, so I don't know if everybody knows this, but we do this for a lot of our clients, and I think it's kind of fun. Um, where we'll jump on a Zoom, or if we're in town, we'll walk into the office and we'll do like an hour lunch and learn where everybody gets to eat lunch. And I kind of talk about whatever it is that you want me to talk about for that hour. We can do that for Rust as well. So if you think that your team, I don't care how big or small the team is, if you think your team would enjoy like a lunch and learn or jump on a Zoom, I don't care if it's even 5 people, reach out. I love doing that kind of stuff, and we can talk about anything you want, and it's a lot of fun. So if you want to do a lunch and learn, just reach out to MJ. I don't care how big or small a team is. I want to talk about Go or Rust. I'd love to meet you and see what you're doing and see if I can help answer any questions. All right. Apparently, we're giving away some free tickets to the next couple of classes here. Eric, tell me how this works again in terms of if they win, they can choose the class they want to go to. Okay, so let's spin it.
Oh, that's pretty.
While we're waiting, hey Vlad, I love your question. Can you send that to me in an email? Because I just can't answer it here. And I want to answer it and I want to think about it a little bit more too. So, Vlad, when you hear this, bill at ardenlabs.com, send that question over to me and we'll explore it.
Yeah, and if you have questions, my email address was underneath my name for most of it. It's Herbert Wolverson at ardenlabs.com. Um, happy to try and answer. So
Eric, just remember there's a 30-second delay here. So, doo-doo-doo. I don't know for 30 seconds in. That's the only problem with this spinner on these live events. Well, you know what? If your name was there, then you'll say it and you'll get it. And if your name showed up next, we'll deal with it. So, all right, do it again. Do it again. Well, we have 95 people here. We should almost only add people as they enter into the chat. All right. Well, while we're waiting for names here, um, while we're waiting for someone. Oh, this is big. I started singing. All my kids think they live in a musical because all I do is I walk around the house and sing. Now, if only I had a voice. I keep telling them I'm gonna go on American Idol next year. I don't think there's an age limit, is there?
I
I
don't think
think
so. You know,
there used to
one nice thing about having a toddler is that I can sound off key and she still thinks it's good. So I've got a year or two left.
be. Eric, somebody better win. I'm going to start singing, and then it's gonna get ugly. Oh, you have the chat. Why didn't we think about that? We don't have to wait for the delay. We just have the chat, and then we have the name. Oh, yeah, that's right. So, Eric, after you spin it, just drop in the Eric. Drop in the chat the name of the winner. When you're a jet. Oh yeah, man. Oh, in the musicals, right? Talking about a West Side Story. Jet, 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 jet. I don't remember all those songs. My favorite musical one, Guys and Dolls. Ian, have you seen Guys and Dolls? I mean, he's like, no, stop singing. Eric, you know what Eric does to me? Sometimes when we're in a live class and it's being recorded during breaks, I forget it's being recorded. And then next thing I know, there's like a bloopers reel that comes out with me doing dumb things.
Yeah, I'm so
So,
glad that I didn't get that from my first class.
yeah. Well, so Ian, Guys and Dolls, right? One of my favorite songs. Luck Be a Lady Tonight, right? Great song. I'll walk around the house singing that one. I cannot believe that none of these people are here. Wait, 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 wait. I just saw somebody
Nope,
say
there's
hi.
Mansoor has won. I think
Yay!
that's how you say it.
Yep, we got a winner. Winner, winner, chicken dinner. Winner, winner, chicken dinner. So what are we waiting for? One more winner? Yeah. Okay, so we got the one winner. There it is, it's live. So they get to choose what class they want to be in. And now the next name is dun 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 dun. Emily. Emily's got four names. Well, God, I wish I could pronounce names. Olivia Allen Davis. There we go. So let's drop that name in the chat. Let's see. Let's see. No. Dropped it in the chat. No. There we go. Winner, winner, chicken dinner. What is that a reference from? That's a good question. Obviously I didn't make it up. Let's see. Winner, winner, chicken dinner. Uh, that's funny. There's even an urban dirt.
Oh, Alan Davis is here. We have a second winner. So
Yay! Let's
I'm afraid
see.
we randomly just picked Peter Schwang, who didn't win.
The exact origin of the phrase winner, winner, chicken dinner is disputed, but it may have come from gamblers. The most popular original story of the term. Wow, look what we learned. Forget about Go and Rust. We learned about winner, winner, chicken dinner. I can't even tell you where I got that from. Wow. So we got two winners, right, Eric? We're good. Okay, looks like we got our two winners. Yay! Okay, so we've done everything that marketing has asked us to do. We've talked about Go and Rust. If you have any other questions, comments, things you want to share, I'm going to drop my bill at ardenlabs.com. There it is. Send me questions. Go for it. And I will usually pretty good at getting back to everybody within 24 hours. So we'll make that happen. Hope to see everybody either in that class or online or next year after the summer or starting in the summer. We got some cool Go conferences coming up. GovCon EU, GoLang UK, the Italian conference. We've got there's
Yeah,
another one. The US.
I'm hoping to see people at RustConf in Albuquerque.
Oh, I've never been to New Mexico. It's kind of interesting. I think I'm going to be going to the RustConf. I've never been to
I
New
think so.
Mexico.
I've been
That's kind
through
of
it, just never stopped.
okay, but I'm going to be in London, Berlin, Florence. I might even be in Singapore at the end of the year, San Diego, and New York. So the second half of the year is going to be fun. So try to get to one of those conferences. Find me, say hi, buy me a drink. No, I'm kidding. I'll buy you a drink, and let's just have some fun. All right, we're good, Derek.
Cool. Thank you.
We're gonna roll. Okay, I'm rolling everybody out. Here we go. Roll.